So today we are going to continue with our exploration of functions. We are going to be doing four main things today. We are going to find function values. In other words, we're going to find the output for all of our input. We're going to determine if a point, an xy value, is actually a solution to a function. We are going to look at a graph of a function and determine some points. And then we are actually going to graph a function on a coordinate plane. So what I have right now are our four problems. First, we're given this function, y equals 6x plus 1. What we want to do is find the function values, or the output, the y, if we're given these to put in for x. So these are our input. We're trying to find the output. So I'm just going to make a little chart here. So these are my x's, these are my y's. So if I put 1 in for x, and do the math, so use our PEMDAS, 6 times 1 is 6, plus 1 is 7. So my output is 7. If I put 2 in for x, 6 times 2 is 12, plus 1 is 13. If I put 3 in, 6 times 3 is 18, plus 1 is 19. And then finally 4, 6 times 4 is 24, plus 1 is 25. So we just found our outputs, or our function values, or our y values for all of these inputs. Now say we had this function, y equals 4x. We want to determine if the point 2, 12 is a solution. So what we do is we substitute these values in to our function. Remember, the first value is always your x, the second value is always your y. So if my y, I'm just going to rewrite this here, give me more room. If our y is 12, we want to determine, that's that question mark there, 4 times and then 2. So does 12 equal 4 times 2? Does 12 equal 8? No. So the answer to that is no, 212 is not a solution to y equals 4x, this function. Let's go on over here. Say we have this graph that is drawn here. We want to find out the function values, the y values. In other words, what point on this line happens when x equals 1. So if this is our scale of 1, we look at it here, and I know my graph isn't that great, but we say we can go on up, okay, and it shows that at 1, we have a y value of 2. When x equals 0, so that means at the origin, where is my function value? Where is my y value? So we go on up until we hit this point. It looks like at y equals 1. And then when x equals negative 1, which is here, what is my function value? Where is it on the line? And that is at y equals 0. And then finally, we're given a function, in this case, y equals x plus 3, and a blank coordinate plane. And we need to draw a graph of this. So what we can do for now, just because we're starting this, we are going to draw a t-chart, x and y values, and we are going to just select some numbers that we can do to plot points and then draw a line. That is the way we start out graphing functions. So we want to pick any number for x. That's kind of easy. I like easy numbers. So 0. If we picked 0 for x, 0 plus 3 gives us 3. What happens if we put in 1? 1 plus 3 equals 4. What happens if we put in negative 2? You can do that too. Negative 2 plus 3 equals 1. Really, all you need is 2 points to draw your line. I like to do 3 just to make sure I'm doing it right. So I'm going to graph these. Graph the point 0, 3. So 0, 3. And then 1, 4 is up here. Negative 2 So I have these points. Now I'm going to take a straight edge. You can use a ruler, you can use a note card or a folded piece of paper, and I am going to draw a line through all of those points. And I'm going to put arrows at the end because that line goes on forever. So we found function values, or our output. We determined if a point was a solution to this function. We determined function values, or our y values, given a graph. And then we actually constructed a graph given a function. Now go practice.